The last topic in the inverse function section is the inverse function property, which states that two functions, f of x and g of x, are inverses if f of g of x is equal to x and g of f of x is equal to x. So that is the composition from the previous section where we're plugging one function into the other function. This is the fog and the goff. So for fog, you're taking f and you're plugging the g function into the f function. So this would be 3, I'm going to leave a open parentheses, plus 4, and I'm going to plug in the other function, and we'll notice that if we simplify this, the 3's are actually going to go away, and we have x minus 4 plus 4, and then the 4's are going to go away, and we get x. So fog is equal to x, and that's what they're talking about here. If we do goff, or g composed with f of x, then that's the reverse. I would take my g function and then plug in my f function. So on this one, the 4's cancel out first, and that'll be 3x over 3, and then the 3's cancel out, and it's equal to x. So both cases are equal to x. So anytime you have a function and its inverse, or if you're trying to show that two functions are inverses, that's what this one wants us to do. They want us to show that f and g are inverses. Then if you run through the fog and goff, they should both be equal to x. And if that's the case, then the original two functions are inverses. Let's actually do one more. Let's look at 17, which is a very different problem. It doesn't have anything to do with the inverse function property, but it has to do with properties of inverses. And it doesn't really take that long. It says consider the one-to-one function f with values f of negative 5 is equal to 2. What is f of negative 1 of 2 equal to? So essentially, because your domain and your range are always flipped when you find the inverse. So you always swap the x and y, or swap the domain and range. So on the first one, you plug in negative 5 and you get 2 out. So here, if you plug in 2, you're going to get negative 5. So you're just switching, you're interchanging your negative 5 and your 2. And that's really like that for any value that you're plugging into the original function and then the corresponding reversal for the inverse.